Hello everyone, welcome to Extra Marks Live classes. In this session today, we are going to discuss about matter and states of matter. Okay, so we will be focusing on a number of things, a number of concepts related to matter and the particles of which matter is made up of. So what all are the concepts which are going to be covered in today's session? We'll be understanding what matter is, how to identify a matter. We will talk about the particle nature of matter. If we talk about the physical nature of matter, we say that matter is made up of a number of particles. Okay, each and every matter which is present around us is made up of particles. It is a collection of a number of particles. So that is what we'll understand in detail. And then we'll have a look at some common properties which particles of matter possess. Each and every particle, irrespective of what kind of matter that particle belongs to, it possesses those properties, those characteristics. So we'll be talking about characteristics of particles of matter, and then I will introduce you all to three common states of matter, and out of that we'll be discussing in detail about the solid state of matter. Okay, so let's proceed. First of all, I would like to start the discussion with a word known as Panch Tattva. Have you ever heard of this term Panch Tattva? This Panch Tattva is a Sanskrit word where Panch means five and Tattva means elements. Each and everything in this universe is actually considered to be made up of five elements, which we call Panch Tattva. And what are those five elements? The first one is fire element, Agni Tattva. Second one is water element, Jal Tattva. Third is earth element, Prithvi Tattva. Fourth is ether element, that is Akash Tattva. And fifth one is air element, Vayu Tattva. So each and every thing on this planet is actually considered to be made up of these five tattva, these five elements. Now, we in day-to-day life are able to see a number of things, isn't it? Right now also, if we see around ourselves, we are able to see a number of things, isn't it? I'm holding this pen in my hand, I'm having this remote in my hand, I'm able to see a table in front of me, laptops, mobile phones, copy, book, water bottle, water inside the water bottle, all these things, isn't it? Don't you think all these things have different properties? Obviously, all these things have different properties. They are of different size, they are of different volume, they have different shapes. So yes, can you also name a few things that you see around yourselves and analyze if they have different properties or not? If they are of different shape, size and volume or not? The answer will be yes. You also will be able to see around yourselves and identify a number of things which have different size, shape, different volumes, and they have different properties. Now you must be thinking, ma'am, why are you asking us to identify these things and you are making us realize all this? Because everything that you are seeing around yourselves is matter. How do we define matter? We define matter as anything around us that has some mass, that has some mass and occupies some volume, or say occupies some space. So anything that has mass and has volume, anything that has mass and occupies some space and can be perceived by any of our senses is known as matter. You can label that particular thing as matter. So if I talk about water inside the water bottle, the water is also a matter because that water is occupying some space, it is filling up the bottle, it is having some mass. The water bottle itself has some mass and it occupies some space in the universe. So anything that occupies a space and has some mass, most of the matter is visible to us, but there are a few matter which is not visible to us, like the air around us. The air around us is also made up of particles. It is also having some mass, it is also occupying some space. And we cannot see it, but yes, we can feel it through our skin. When air breezes, we are able to feel its presence. So it should have mass, it should occupy volume, it should have some volume, occupy some space, and can be felt by any of our senses, is known as matter. Let's have a look at a few examples. Banana or any other fruit, any other edible item that you see inside the kitchen, the phone, pen, car, milk, rocket, book, school bag, school bus, Activa, scooters, whatever, plants, the pots in which the plants are there, All these are matter. Now you must be thinking, ma'am, what this atom is. Okay, we have never heard of atom. We are not able to see atom because all the other things which are mentioned here are visible to you. Okay, but atom is not visible. Still, I am considering it as matter because atom is the term which is used for smallest particle of any matter. All the matter that you see around yourself, let's take example of this pen only. The pen which I am holding in my hand, it is not continuous in nature. What do I mean when I say continuous in nature? I will call this pen continuous in nature when it is made up of just one particle. But I am saying it is not continuous. That means the pen which I am holding or any other matter that you are able to see around yourselves is not made up of just one particle. It is made up of a number of particles staying together with stability. So, atom is the term which is used for smallest particle of any matter. Smallest particle of any matter is known as atom. But yes, atom also has some mass. It also occupies some space and hence it is there as an example under the heading of matter. So, how do we define matter? We define matter as anything that has some mass and has volume. That means it occupies some space, is known as matter. Now, I am again and again using this word mass. Let's understand the meaning of mass and also differentiate it from a similar term, that is weight. Most of the time, or say a number of times, we use these words as synonyms of each other, mass and weight. But let me tell you that mass and weight are two different terms. They are different from each other, and in value also they are different from each other. Mass, concept wise, if I talk, mass is the measure of amount of matter present in any object. Okay, so mass will vary with the amount of matter present in any object. If you know the mass of any substance, you can get an idea on how much matter would be present in that particular object, inside that particular substance. So, mass is the measure of amount of substance present in any object. But if I talk about weight, weight is the measure of gravity's pull on an object. If I tell you mathematically, we get the value of weight when we multiply mass of any object with acceleration due to gravity. Acceleration due to gravity, we study it in physics. You will also get to study it in physics. Maybe you will be studying it right now, or in the upcoming sessions you will get to study that, what is meant by acceleration due to gravity. So, mass of any object multiplied with acceleration due to gravity gives us the weight. Right now, we are not focusing on the mathematical part or expressions for their calculation, but yes, I want you to understand the difference in between them. Whatever matter is present at a place or inside any object will give you the mass of the object. But weight is always more than mass because we multiply some specific value, and weight of a person will vary from planet to planet. From like if I compare the weight on Earth and Moon, the weight will be different. Why would weight be different? Because of difference in the acceleration due to gravity. So, weight is the measure of gravity's pull on any object, and mass is the amount of matter present in any object. When we talk about matter, we are concerned with mass and we are not concerned with weight, because weight, mass is always fixed, whether it is sun, moon or earth, although we cannot go on sun, but whatever place it is, the mass remains constant but weight will vary. So, we will be talking about mass. Okay. Now, I have also used the term volume. What is meant by the term volume here? Volume is the amount of space occupied by any substance. Okay. So, by looking at the volume of any substance, any object, you can get an idea how much space it is going to occupy. There are several words which we use to express or say describe volume of different substances. We say it is big, it is small, it is little, it is large, it is long, it is short. So, these terms are used as adjectives to talk about volume of any substance, and these words gives us the idea about volume of any substance. Okay, have a look at these images. Some of the blocks are small, some of them are big, some books are long, some books are short. So, this is how we talk about volume, and technically volume refers to the amount of space something occupies. Okay, now I have a question for every one of you. Let's read the question together. What does the question says? Question says, which of the following is not matter? Okay, based on your understanding about matter, just now I have discussed and I have told you how you can identify matter. While identifying matter, what you should keep in mind? You should keep 2-3 points in mind, that anything you are labeling as matter should have mass, it should have some volume. Okay, so anything that have mass and have volume, that means it occupies some space and can be felt by any of our sense organs, is matter. Okay, so one example I would like to give: your emotions. Your emotions are your feelings. They do not have any mass, they do not occupy some space in this universe. So emotions, your own thoughts, these cannot be classified as matter. But yes, the chair, the table, the air around you, all these can be labeled as matter. So keeping all these points in mind, try to find out the answer to this particular question. Let's move ahead and let's talk about the physical nature of matter. Physical nature means, this we have already discussed. I have told you that matter is made up of particles. I have told you the particulate nature of matter. I have told you that each and every matter that we see around ourselves is made up of particles, and that is why we say that matter is particulate in nature. It is made up of number of particles. Okay, number of tiny pieces staying together with stability gives us a matter. Now, these particles which are present inside a matter can be atoms or molecules. This you need to understand. Although we are going to discuss about atoms and molecules in detail in the upcoming chapters, but yes, for now what you need to understand is any matter from inside could be made up of atoms or molecules. What are molecules? Molecules are the groups, or if I talk about a single molecule, a molecule is a group of two or more than two atoms chemically bonded together. Okay, so whenever two or more than two atoms come together, they bind with each other, we get a molecule. Have a look at these examples here. This is the molecule of hydrogen, this is the molecule of water. Both of them are groups. This is a group of 2 atoms, this is a group of 3 atoms. So inside water molecule, 1 oxygen atom and 2 hydrogen atoms, they chemically bind with each other, and after binding, they act as one single particle. Now these 2 hydrogen atoms will not be acting separately, they will not have their own identity, neither this oxygen atom will have its own identity. Oxygen atom combined with 2 hydrogen atoms is now just one particle, and that one particle is the smallest particle for water. So when we see inside a matter, if we get a chance to see inside a matter, inside a few substances, you will be able to see atoms as particles, and inside a few you will be able to see molecules as particles. And what are molecules? Molecules are nothing but group of 2 or more than 2 atoms chemically bonded together. And one more thing you should remember, that particle of one matter will definitely be different in terms of properties and all properties from the particles of another matter. So in general, we'll be discussing in the upcoming chapters in detail about the atoms and molecules. But yes, in general, we say that the particles differ from one kind of matter to another kind of matter. Okay. Now, I have told you, we have understood that, we have concluded that yes, matter is made up of particles. Any matter that we see around ourselves is not just one particle, it is made up of it is a collection of a number of small particles. These particles of which matter is made up of, they possess some characteristics. Okay, what do they possess? They possess some characteristic properties, and these are the 4 common properties which are possessed by particle of any matter. The first property here is that they are very small. It is about the size of these particles, atoms and molecules. They are so tiny that they cannot be seen with naked eyes. So particles of any matter are very small in size. The second property is they have spaces in between them. This space is termed as interparticle space. Why I am calling it interparticle space and not specifying it as interatomic or intermolecular space, because we are talking in general for now. So whatever be the particle, be it atoms or molecules, they will have some space in between them. Okay, so this is the second property possessed by particles of matter. Coming on to the third property, the particles inside the matter constantly try to move. They are in a state of continuous motion. Yes, the degree of movement will vary from matter to matter, from state of matter to another state of matter. Okay, so they are constantly moving. That means they possess some amount of kinetic energy. What is kinetic energy? Kinetic energy is the energy by virtue of which any particle shows movement, shows motion. So, depending on the amount of kinetic energy present, the degree of movement will definitely vary. But yes, this is true for particles of each and every matter, that the particles are constantly moving. So, this becomes our third property. No matter about, doesn't matter for which kind of particles we are talking about, atoms, molecules, all of them possess these general properties. The fourth property here is the particles inside the matter constantly attract each other. They constantly try to attract each other. The force of attraction existing, operating in between the particles of any matter is known as interparticle force of attraction. Okay, at a few places you will be able to see and hear intermolecular forces of attraction, but yes, right now I am writing it as interparticle forces of attraction, the attractive forces that exert, that exist, that operate in between two different particles of matter. Okay, so if I talk about an iron rod, okay, what do I have? I have an iron rod, and these are the atoms present inside the iron rod. Each and every atom inside this rod will attract each other. Okay, so first atom will attract second atom, second will attract first, and this is how they'll keep exerting attractive forces constantly on each other. That property, hence we say they attract each other, and the attractive forces are known as interparticle forces of attraction. Okay. Now, let's verify all these properties one by one with the help of some activities and examples. The first property that I told you was the particles of a matter are small, isn't it? They are very small, they cannot be seen with naked eyes, but their presence can be felt, their presence and their small size can be verified with the help of one activity here. Okay, what we need to do, we need to take 6 beakers here. We need to take some water which will fill in these beakers, and we need KMnO4 crystals. These KMnO4 crystals are purple in color, dark purple color they possess. They are purple color particles. Okay, what we do, we take 6 beakers and we fill water in all these 6 beakers. Now we take a crystal of KMnO4, a small piece of KMnO4, and we drop this crystal into the first beaker we have. As soon as this KMnO4 goes inside water, it will dissolve, because KMnO4 is water soluble. So KMnO4 will dissolve in water and it will produce a dark purple color solution. Now what we need to do? We need to transfer 10 ml out of this purple colored solution present in beaker 1 to beaker 2. As soon as we add 10 ml from first beaker to second beaker, the water inside the second beaker also becomes colored. And same thing will keep on repeating. Every time I add 10 ml from the previous beaker to the next beaker, what happens? The color also gets transferred from the first to second, second to third, third to fourth beaker. What is responsible for transference of color? We dropped just one single crystal. If this single crystal was just one particle of KMnO4, the color would not be transferring from one to second, second to third beaker. This happens, this transference of color from one to another beaker occurs because this single crystal of KMnO4, or say the single drop which goes from first to second beaker, consists of millions of small particles of KMnO4 which gets transferred along with the water. So it was not just one particle that went inside when we dropped the crystal. These were the millions of particles that got into this water, and when we are transferring, although the intensity is decreasing. The color is fading away because the number of particles which are present over there are less. But yes, the particles are so small to be seen with naked eyes. But yes, this activity verifies their small size and they are getting transferred, imparting color to water present in the next beaker as well. Okay, so they keep spreading and imparting color to more and more amount of water. The next is they have space in between them. Let's verify this property as well with the help of one example here. What we need to do is we need to take some water in a beaker or in a glass like this and a salt in a dish. Okay, a salt means salt in a dish. Some amount of salt in a dish we'll take. What we'll do? We'll fill water in the glass and we will add some amount of salt into it and then we'll stir it. What will be your observation? Will you be able to see salt particles staying here? No. Will the water level rise? No. You can again observe this image here, this small video here. Water is filled. Observe the level. Now salt goes into the water and then we stir it. Is the level of water rising after addition of salt? No. The level of water is not rising after addition of salt. So what does this indicate? Where is the salt going? Matter cannot be destroyed. Okay, so the salt is still there. If you look at this water at molecular level, what you will be able to see? You will be able to see that there is space present in between the particles of water. If these are the molecules of water, there is some space present in between, and this is the space I was calling interparticle space, isn't it? The space present in between the particles of a matter. For this, in this particular case, the particles are molecules, so I can call it intermolecular space. And the salt particles occupy, see, the crystal of salt will disintegrate. As soon as it goes into water, it will disintegrate and all the salt particles will occupy the intermolecular space present in between the molecules of water. So the level is not rising because there was a space available to accommodate the salt particles, isn't it? So this activity verifies that yes, the particles of matter have space present in between them. Let's move to a question to understand this in a better way. Let's relate this property through some day-to-day life example. When a diver dives into a swimming pool, the diver is able to cut through water so easily. The head of the diver does not bump with water, isn't it? Why does it happen? Which property of matter does it shows? Actually, when a diver jumps into the swimming pool, what happens? The water gets displaced, and if the particles of water are able to move aside, there must be space available, isn't it? So yes, a diver is able to cut through water in a swimming pool because of presence of interparticle space in between the water particles, and it shows that particles of matter have spaces in between them. The next property is that the particles are constantly in motion, and as I told you, the energy by virtue of which the particles move, the energy possessed by any body, any object, any particle by virtue of its movement is known as kinetic energy. Higher the kinetic energy, higher will be the degree of movement. Okay, please remember. Higher the amount of kinetic energy possessed, higher will be the movement shown. And because they are in a constant state of movement, the particles of a matter travel from a region of higher concentration to a region of lower concentration or on their own until the concentration becomes equal on both the sides. This is known as diffusion. So we say that because the particles of a matter are in a constant state of motion, they intermix with each other. If we take two different parts matter, suppose I take two different gases and bring them in contact, the particles of those two gases will intermix with each other, isn't it? The smell of the perfume mixes with the air. How does this happen? This happens because of diffusion of the particles of perfume into the air. While diffusing, the particles of two different matter intermix, they diffuse, they move, they occupy the interparticle space present in between them. And why they are able to move? Because they possess some amount of kinetic energy. You should also remember one thing, that kinetic energy of particles increases on increasing the temperature. With the increase in temperature, the kinetic energy also increases, and hence at higher temperatures, the particles move at a faster rate. If the particles are moving at a faster rate, what will increase? The speed, the rate at which diffusion is taking place will increase. Let's revise what is diffusion. Diffusion is the movement of particles of any matter from region of higher concentration to a region of lower concentration on their own without any external efforts, until this process will continue until the concentration at both the places becomes equal. Okay, so they show a property of diffusion, and have a look at this image here. This shows how the motion of particles vary in three common states of matter. Matter exists in three common states, that is solid state, liquid state and gaseous state, and the particles in the solid state are not leaving their fixed positions. What you are able to see here, what we are able to see here, that the particles are vibrating at their fixed position. So yes, this is what happens in the solid state. The particles are not able to leave their fixed positions and they just vibrate at their own positions. If I compare the movement in liquid state with the solid state, the movement is a little more, and if I compare the movement in gaseous state with other two states, the movement is maximum. Yes, so the kinetic energy is maximum in gaseous state and it is minimum in solid state. Now let's have a look at the examples of diffusion in day-to-day life. See, whenever we make coffee or nimbu pani, what happens? We add lemon drops to the water, and the whole water gets the sour taste of lemon. How does this happen? The particles which were present in the lemon drops, they diffuse in between the particles of water and they intermix with each other. So this is an example of diffusion that we experience in day-to-day life. Similarly, when someone wears perfume or we burn incense sticks, the smell of perfume is not restricted, it is not confined to the person who is wearing it. Everyone in the surroundings in the same room are able to smell that perfume. How does it happen? It happens because the particles of perfume diffuse into the air and they travel and reach to the nose of other people as well. Similarly, when we burn incense sticks in one corner of the room or in one room of a house, the smell is spread all over the house. How does it happen? When the food is cooked inside the kitchen, its smell we are able to smell it outside in the hall as well, isn't it? So how does it happen? This happens because of diffusion of particles, because of the intermixing of particles of these substances with the air particles. So these are the day-to-day life examples of diffusion. The last property is they attract each other. That means the particles of matter are held together by some attractive forces. How do we verify it? Let's perform one activity here. We need a chalk piece, we need a wooden block, and we need one iron nail to perform this activity. Whatever out of these three substances you try to break will require some kind of energy. Even breaking a chalk will need some input, isn't it? It will not break on itself. If we keep the chalk piece on a table, it is not going to break on its own. We need to put in some energy there. When we try to break a wooden block, we need to put in some more energy, and if we try to break iron nails, we need to put more energy, and maybe we'll not be able to break it. So from this observation, what we can conclude? We can conclude two things here. Particles inside any matter are held together by some attractive forces, because even breaking a chalk needs some energy, isn't it? So that energy is actually used in overcoming the forces of attraction present in between the chalk particles. Okay, if we want to break the particles and we want to break the chalk and move the particles away from each other, we need to put in some energy to overcome the attractive forces existing in between the particles of chalk. We need energy to break a wooden block, but the energy is more. The required energy is more than the energy required for breaking the chalk. Why? Attractive forces are here also, there also, but the strength of attractive forces is more in case of wood, and it is even more in case of iron nails, isn't it? So yes, what we can conclude, the particles are attracted to each other through some forces of attraction, and the magnitude, the strength of these forces vary from matter to matter. Now let's talk about the states of matter. Based on the physical properties we can classify matter in 3 different classes: solids, liquids and gases. Let's discuss about solid state in detail. Solid is defined as that form of matter which possesses rigidity. Okay, so solids are rigid. They are incompressible. Any substance in its solid state will be rigid. What does this mean? If it is rigid, that means you will not be able to change its shape, size, its volume will remain fixed, the boundaries will be fixed, it will be incompressible, it will not be expandable. So that is what rigidity means, and they are incompressible, and these two properties are responsible for definite shape and definite volume of solid substances. If you have a look at the molecular level of a solid, you will be able to see that the particles inside a solid are closely packed to each other. They are so closely packed that the interparticle space is minimum. Yes, please remember, the amount of space present in between the particles of a solid is minimum. If we compare the interparticle space with liquid and gaseous state, the solid state is having minimum interparticle space and maximum density. So we say that solids have fixed shape, fixed volume and fixed boundaries. Have a look at these 3 examples here. Bat and ball, their shape and size does not change. The statue which is like there in the park, its shape, size, its boundaries remain fixed. Its size does not change all the time. If we talk about pencils, pens that we use in writing, the shape and size remains fixed. So we say that any substance in its solid state is incompressible. Have a look at this pen here. This pen here is incompressible. No matter how much external force I apply on it, it is rigid. It is not changing its shape, isn't it? Its size is not changing. It is having fixed boundaries. And this happens because the particles are closely packed with each other and they are fixed at their positions. The degree of movement is minimum. I told every one of you, like, let's go back there. Okay, and I told you, I showed this to you. We were able to see that the particles are not able to leave their fixed positions because the kinetic energy is very, very less. Kinetic energy here is not sufficient to overcome the forces of attraction. Hence, the particles are not able to leave their fixed positions. They are just vibrating at their own places. And this is responsible for a fixed shape and size. Okay. So, for solid state, we say that there is fixed shape, fixed volume and fixed boundaries. Okay. Now, if I talk further about the properties of any matter in the solid state, particles which could be atoms, molecules and in some cases they are ions as well. In the upcoming chapters you will be able to understand this. In solids are packed closely together and that is responsible for their high density. But the question is why they are closely packed? See, the strong attractive forces existing in between the particles of solid are responsible for their close packing. So we say that due to greater force of attraction between the particles of a solid which holds them together tightly, their positions are fixed, giving rise to a definite shape. So if someone asks you why solids have a definite shape, this is the answer. This is the reason. Strong attractive forces existing in between particles of a solid are responsible for fixing the particles at a specific position and giving the substance a definite shape. Okay. Now, the particles, the forces in between the particles are so strong that they cannot move. Okay, that means, and that is the reason why they can just vibrate at their own places, and this makes solids rigid. They're able to maintain force even when we apply some external pressure on them. And one thing you should remember, that the strength of intermolecular forces of attraction, interparticle forces of attraction is maximum in solid. They are the strongest in solid state. Okay, have a look at here. The particles are just vibrating. They are not leaving their fixed positions. Okay, this you should remember. So if I talk in terms of 2 different properties or say 3 different properties, interparticle space is minimum in solids, kinetic energy is minimum in solids, and intermolecular forces of attraction are maximum in solids. Okay, so this you should remember. Now there are 2 exceptions in solids. The first is a sponge. A sponge is a solid, even then still it is compressible. Okay, you must have seen that we can compress a sponge. what happens? The unique structure of a sponge is responsible for this. Inside the structure of sponge, there are a number of pores present. And these pores contain trapped air. When we compress, when we apply pressure on a sponge, the air from these pores move out and we are able to see a compression. Okay. Now again, when we see sugar crystals and when we fill sugar in two different containers, the shape of containers is different, we get a feel that the sugar is changing its shape, which is not a property of solids. Then too we consider sugar as a solid. My dear students, here you are getting confused. When we see sugar changing its shape, we are able to see collection of a number of sugar crystals. It is not just one sugar crystal. If you focus on just one sugar crystal, you will be able to see that the particles inside the single sugar crystal are not changing their places, they are not changing their positions. So, we consider it as a solid because the shape of individual sugar crystal remains the same, isn't it? It is a group of the crystals which when filled in different shaped containers are occupying the shape of the container, but the position of the particles inside a single sugar crystal is not changing. Okay? Now, I have a few practice questions for every one of you. I am giving you 3 questions to practice. What you need to do is you need to read these questions and try to write answers to all these questions based on your understanding from today's session. And I'm pretty sure that you all will be able to do it. And let's quickly recap what we have discussed and understood. We discussed about matter. We understood what is matter, how to identify matter, what are the characteristics associated with particles which are making up matter. And then with the help of some activities with day-to-day life examples, we verified those properties. We just had a look on the 3 basic states in which matter can exist, and we discussed about the solid state of matter in detail. I hope every one of you properly understood everything in today's session. That is all from my side. Thank you.